time. So let's get started with the ONOS performance Scrum, and as usual, let's use the let's start from the bottom. So let's start with the flow performances improvement.
I can cover. Ali, unfortunately, is not here today, but there was a lot of improvement made to the flow rule service. If you remember, at the end of last sprint, we had the API redefined and the implementation started, but there was a lot of time spent this sprint getting it to work. So we completed the implementation of the flow rule service. It's been merged to master. We also spent, mostly Ali spent a better part of the sprint doing test profiling and developing in a cycle. So he would do some testing and profiling, discover where some bottlenecks are, and then use that to make the system better and faster. Through that, he also gained a pretty significant understanding of how the system works and where the time was being spent. And for that, there's a report linked here from the doc. You can read that at your leisure. There were also a number of bug fixes that were discovered over the course of the week that were fixed as they were found. And so the flow rule service is looking like it's looking in pretty good shape. The other thing is the next sprint will mostly be spent on hardening and getting distributed numbers. So on the intent service, there was also a lot of work done, although we're not quite at the same end state that flow rule service is at yet. If you remember last time, we had redesigned the intent service API, made it simpler, easier to program, and also reduced the implicit contention or serialization between applications or within an application. So there was a group of us, Ray, Sho, Jono, Thomas, and myself, that spent some time sort of ripping the code apart and putting it back together. And so to sort of highlight the bullets here, now we've got this notion of keys in the code. A key is specified by a user application if they desire, and it's used to identify a policy. We remove serialization between requests from a single application, and we also introduced the concept of an accumulator to avoid falling behind. So applications can submit policies at whatever rate they want. And the idea of the accumulator is that it'll aggregate policy or intents of the same policy over time, and then it's able to fast forward through to the latest policy. We also had to redesign the intent store API. The reason for this is because the interactions are key-based, so they're based on policy ID. Implemented a new partitioning strategy, and that's used to distribute the work and avoid serialization. We refactored the state logic into different classes. This was primarily work that Sho drove. And this reduced the code complexity. It made Intent Manager half the size, and it makes the code and logic more readable. And also helped us find a couple of bugs that we had in the more complex monolithic version. Finally, we also broke a lot of tests along the process, and all the tests that we currently have now pass. Many of them had to be rewritten. We also use them to discover a couple of bugs and fix them.
Should that key be used as a priority for the intent? Suppose say there is a security intent, and the way Ali mentioned yesterday, thread-based, each thread, each device will get separate thread. So if there is a security intent being pushed on, and system is busy processing already accumulated intent, would that get the priority so that will be get executed first?
Are you asking?
Yeah.
Okay, so maybe we can just summarize the question. So the question is, are we using application ID or key as a basis for prioritization? And the answer is we're not right now, but you could imagine a system that did. You could implement that logic because the information is available. And we'll get to a talk in just a few minutes that talks about some of the roles that we're thinking about introducing to ONOS, and that would also be another basis for doing this. So it's not on our current roadmap, but you'd imagine it would be a supported feature in the long term. So although we did get a lot done, we didn't sort of, oops, okay, one before. Although we got a lot done, we didn't quite get to where we wanted to be. We wanted to have some numbers today, which unfortunately we don't. But the good news is that we've got a system that can do sort of basic functionality. We can do basic stress tests. We wanted to do a little bit more testing to ensure that the use cases are working and that we sort of work at scale, both in terms of number of intents and number of nodes, before merging to master. This whole branch will hopefully today or early next week. Once it's in master, we've got a couple of things on the front. We've got some bugs that we know will evolve and emerge that we need to fix. We want to do some cleanup of some comments that was left in the code. We want to take another look at the error code path. So when compiling, coordination, installation, withdrawing fails, we want to make sure that we handle all of those cases so we don't get ourselves into an inconsistent state. We've talked about adding a new state to the state machine to handle certain types of transient errors, and we need to improve our unit test coverage. These have been sort of invaluable in making sure things work as expected, and have helped us find bugs and coverage we'd like to improve. We've got one more slide which talks about our plan for performance. So we do plan on getting some performance numbers by the end of the release. And so we've started some initial JProfiler analysis, but there's much work to be done. We plan on doing similar test and profile followed by develop cycles in the next iteration. But the preliminary findings are that we're spending a ton of time, over half our time, in serializing objects for broadcast. And we're also spending a non-trivial, over 10% of our time handling exceptions. And this is because we're using exceptions to drive logic when instead maybe we should be doing something else. So this was just discovered yesterday, and we'll need to take a look at it and sort of retool some things. But you can expect sort of more of this type of analysis and understanding where the rest of the 40% or whatever of the code or time is being spent. We'd like to generate some bare metal numbers. This was stuff that was done on laptops. We're going to need to rethink our test strategy just a little bit because we have the accumulator now in place. The number of submitted is not necessarily the number of installed that you're going to get. That's because requests from the same key can be aggregated. Also, we'd also like to take advantage of multiple nodes through partitioning. We don't have an automated algorithm or mechanism for splitting up the partition, so that will need to be done manually for testing. But that's functionality we hope will come in later. And finally, sort of at a high level, what numbers we'd like to show are absolute throughput for a fixed set of intents, which is already planned but may need to be reworked with the change that I just mentioned. We'd like to measure latency for reroute. And finally, a new test that I think we should take a look at is measuring sustained throughput for continuous updates. So you hammer the API with a fixed set of keys for a fixed duration and see if the intent framework can keep up and what its performance is. So we've already started some development on the dev side to support this test, but it's something we should investigate over the next 2 weeks. And I think that was pretty much the intent. So.
Okay, is Thomas going to talk to this?
Nadan, I think, or maybe.
Yeah.
Hi, this is Thomas. Can you guys hear me okay?
Yep.
All right, yeah, Madan has asked me to give an update on this since he's in flight right now. So he was pretty much working on the multi-consensus string raft store, and he finished the ONOS integration of this. So now we basically have, along with the ability to have the eventual consistent map, now we have a fully consistent map, and it follows a very similar usage pattern. So right now the arsenal of possibilities that we have for implementing distributed stores is been significantly reinforced. We have two abilities to specify how the data is partitioned. You can either partition it by keys, which this means that each key is going to be mapped into its own partition. This allows essentially having the global state divided among the different clusters. alternatively, if you want, you can specify, you can bind the whole map to its own functions, which means that the map will only be distributed partially throughout the cluster. Both approaches have their own. I think the next slide has some content, if you wouldn't mind fast forwarding for me. So both approaches have their own pros and cons. With the partitioning per key, this can result in some network partitions. It can result in portions of the key space not being available. If for example, all of the instances have been partitioned off that carry that majority of the key key partition, and in a downside of partitioning by the entire map. Was that a question?
No question.
Yeah, okay. The caveat, of course, of benefit of there's number of benefits for the partitioning by map, but one of the caveats of that is that it makes partitions across it makes consistent updates between different maps require two-phase commit, which requires more complexity and of course costs some performance. But we have these two possibilities, and applications, depending on what kind of data they need to treat, can choose. And so this significantly, improves our, ability and reduces the amount of complexity that the applications themselves have to implement, or the subsystems themselves have to implement when they're implementing their distributed stores. So what's required still is the cross-partition transactional updates, integration of the resource store with a consistent map, because right now it still relies on the Hazelcast one, and we need to implement the ability to rebalance the leader, because right now what can happen is there can be some clustering that causes heavy loads on some members of the cluster versus and some members remain light, so we want to be able to rebalance that. And of course, as always, it will still require a lot more testing. So that's pretty much all of the update that Madan has provided.
So Thomas, this is very good that it is all. So when you say integrated, that means now, does it mean everything is using this, or what does the integrated mean?
Well, so on the previous slide, what that means, it's in ONOS code base, and it's ready to go. But what first store that we would like to start using this new generic mechanism would be the resource store, and that's work that still has to happen. So the technology is ready, but the work still has to be, and it's available on master, but it has to be still. Work still has to happen to be able to port the consistent stores on top of this new technology. And that's the next step here, starting with the resource store.
So in the intent framework today, there is nothing that is requiring strong consistency, is that right? So
that all depends on where you draw the boundary around the intent subsystem. The intent store itself does not require strong consistency. It by Jono using the eventually consistent map and using the gossip anti-entropy. However, if you draw the boundary also around the link resource store, which is used by some of the intents in order to reserve link resources like bandwidth, lambdas, and so forth, then this is something that we would like to, clearly it needs to be strongly consistent, and this is something that we would like to use the new consistent map. And the work that
But those use cases are not yet using it, is what you're saying, and they're not.
Correct. Correct. Yes. And remember, the goal for Blackbird was to make sure that the multi-ring consensus store is available and it was only a stretch goal to actually make some of the subsystems use it, right?
Okay.
So I think the stretch goal seems to be within reach, at least for the link resource store. So that's good news.
Yeah, I know. So that is good. Very good.
Thanks, Thomas.
Mm-hmm.
I got one more.
Okay, and I can talk to this now. Strictly speaking, this is not part of the performance. This was one of the activities that was used sort of as a filler. And so I worked on the application framework in order to. So what is this application framework? It basically elevates the notion of an application from the mere application ID, which is what we had with release 1.0. The only notion of the application there was just an application ID, an identifier. And the reason we had to have it is so that we can consistently allocate IDs, which were used as part of the cookies and the flows, and for the intents that were emitted by application, so that we could identify who put down what onto data plane. So we've extended that concept by for a number of different reasons. So first, one reason was to allow easy distributed deployment of application-specific code. In the past, one had to push individual bundles up to all of the different instances, and then go to each individual Karaf instance, and then install the feature repository and install those features. This is no longer necessary because one can produce a multi-bundle and multi-feature application as a single artifact, and then essentially upload that artifact to any instance in a cluster, and this will result in a cluster-wide upload. And then one can activate and deactivate the application as a whole from using any of the CLIs, single instance CLIs, or using REST APIs. And so the applications can be packaged both as fully self-contained packages, which means that they contain everything that they need, meaning the application descriptor, the features descriptor file, and any of the bundle artifacts, like the jars and var bundles. But it can also support hollow application packaging, which means that the only thing that the package archive contains is the application descriptor, and everything else would be downloaded using the Maven repository path. So depending on... yes, was there a question?
Nope.
Okay. So depending on the deployment, because if you're deploying on in an environment where you're completely isolated in an island from internet, you're clearly gonna need the former. But if you're connected to the internet, you can actually support you can actually use the latter, and but it has the same benefits. I mean, it has the same effect onto the running ONOS instances. Basically, you can ignite, you can install, uninstall, and ignite and unignite applications with commands against a single controller instance. So it makes it very, very easy. And it'll also simplify application development as well, too, because of the cycle of deploy, redeploy as one works on an application. This can significantly tighten up the dev test cycle and makes it easier and more friendly to develop applications.
Hi, Thomas. This is Shrikant here. I have one quick question. So, would it be possible to install this application only on a subset of the instance in the cluster, or it's installed everywhere in the cluster?
It's installed everywhere because it follows and reinforces the model of symmetric setup. All instances are equal.
Okay, so if I want to... Sorry, go ahead.
Go ahead,
yes,
sorry, Shrikant.
Yeah, if I want to run my application only in the subset of the instances, then I need to follow the previous model where manually go and install only on particular instances. Is that correct?
Yes, but I need to point out that that's really not recommended at all, because that violates the symmetry principle.
Okay.
And it's
I
more.
guess today we have some use cases of SD and IP where only we use in 2-instance model, right? Though cluster has many instances, we max use active standby model.
Well, so the recommended deployment setup is to run the application everywhere, and then if an application needs to be active only in 1 or 2 different places, then it can coordinate. You can use the leadership or log service in order to figure out where it needs to run and then run there. And then in case of failure, you can move the master and the slave somewhere else. So it's much far more flexible to deploy the capability everywhere and then just simply coordinate where it remains active.
Okay, thank you.
And of course, this work is also a basis for the security work that is being done by SRI, because this allows granting and managing permissions on the basis of applications.
Thanks,
That's all I have here.
Should I use my laptop? I'll go with yours, but we have to click on some of the links. So I'll give an update on the test side, on the performance and scale, and also show you some results so far, maybe for a few minutes of a high-level discussion on the results. So what we did this sprint is we set up a 7-cluster bare metal servers, except with the 10 gig cards, because that's still in the back order. The vendor ran out of inventory. On the topology event performance side, we have some results, and particularly on the link event throughput test, we found a couple of issues. We can generate at most with the node link provider with the 700 events per second per node. And also at that rate, we are getting some memory leak issues that we log as a bug to be resolved. And link event side, we pretty much have the script completed, and we have some results to show by Andrew later. And the full performance, we are still working on the test script, but we do have a test results come out from the bare metal last night that we want to show you a little bit. And the intent event performance, based on what Brian just talked about, we might need to have some tweaks on our test script next sprint. That will be our focus on the next sprint. So to start off, let's look at link event throughput test. And the first link, yeah. Just go to the graph. Maybe Cameron's going to explain what this is about.
All right. So basically, the test methodology here was just to use the node link provider to flicker links just to create events. If you scroll up just a little bit to the top of the page, yeah, right there's good. As you can see, we had set the event rate to 2, and this is measuring the pause between link events. So this is actually signifying that we're running 500 events per second, and we're getting an effective rate of about 420 per node. And as you can see, it actually scales pretty linearly. The scaling is actually very, very close. So if you scroll down a little bit again to the graph, you can see this is kind of a strange looking graph. On the far left, there is just the smallest bar is just node 1 on running just one node at a time. And then there's a set of 3 bars next to it that are clustered closely together. Those are the measurements from nodes 1, 2, and 3 when scaling at 3 nodes and so on. So you can see each time you add 2 more nodes, it steps up by pretty much exactly 420 events per second. So
I'm missing something with per node. So what is each bar is per ONOS instance?
Yes.
Yeah.
Per node is per
So we are seeing increase of 2 types, right? Per instance throughput is increasing, and the aggregate throughput is also increasing.
No, actually, what's reported is the aggregate. The graph event metrics is reporting aggregate. Yeah. So they by theory is supposed to be all the same. All nodes should report the same.
But what is showing is the aggregate for each node.
Yes.
Aggregate for all the nodes at each node.
Right. Yes. But there's a little bit of variation, and we graph them all because we had seen some results where there were some differences. So all the data is here for you to look at. But yeah, and as you can see, they're all very close. The aggregate results are very close.
The event, so what is the event doing? So it is coming from, it's a null provider?
The null provider has a link filtering, so just bring the link up and down. So each of that generate one link event.
Right.
So link event got generated, and then the link event generate a graph event in the graph. So we don't accumulate any link event going up to the graph event. So every link event we're seeing is corresponding to one graph event.
Okay.
So this is recording the graph event, which is what whatever the graph every node is seeing. So we're trying to measure the throughput of any event happening on the topology, how that gets reflected onto the graph.
And you're seeing it 420.
Well, this is measured at 421 with a couple of limitations. Like one thing I just mentioned, that the 700 number is the limit of what the node link provider can generate. So the generator can generate at most 721 events per second.
Right.
It's just a matter of the Java code. Right? It's running on one thread, and it's, for whatever reason, that thread is just running at most at that rate. Even we can increase basically on some delay time. The delay time reduced to lower, you don't generate any more higher.
So when you generate an event, it is just a packet?
Oh, it's not a packet. It's just
what does it include?
There's well, essentially, maybe Ayaka can explain better. It's some description of link vanish and.
So basically, the link provider has this notion of this link descriptor, which is a description of an event that it just kind of tries to generate at a relatively fast pace that's affected by the rate setting that the user is giving set. The 700 limit, it's on a single thread, and it might also have to do with some kind of a global clock rate setting, like say in the kernel or something. But that's kind of just a gut feeling. I mean, I can't actually say because I haven't looked into it very much further.
Because I think what I'm thinking is that if it is, so when you say limited by single thread, running on some kind of a machine, right? So even if it is 2 packets or 3 packets, right? So 3 packets times 700, that's pretty small packets.
Well, actually, there's no packet.
What is limiting the rate to 700?
There's no packet here. Right? It's just whatever the provider is
just generating
a description
right.
to the listener saying that this link is up or this link is vanished.
But does it that get sent to?
No, it's all internal to the Java.
Machine, or it's not sent to the machine.
No.
Can I just inject a little context into the discussion? Yeah. So we discussed that this was sort of the quote-unquote performance limitation of a test fixture, right? What we're talking about here is a test fixture. So we could certainly optimize the test fixture, but we decided not to go further with that because it was deemed that this topology rate change was sufficient to stress the system in a reasonable manner and to demonstrate the linear scalability or near linear scalability. So for that particular reason, we didn't really dig into much deeper into improving the performance of the test fixture. This is not necessarily a limitation of the production code.
So perhaps the test fixture is just using a sleep of 1 millisecond. So the reason for the...
I changed that. So I make a change, right? We change it to microsecond level. And even though I go to 500 microseconds, the effective rate stays the same.
But you're using a sleep, right?
Yeah.
And so you're sort of at the mercy of the kernel. And when you
exactly.
the kernel side,
exactly.
It's gonna put you. It can sleep you for like a millisecond. It can sleep you for longer than that, right? That's a minimum time.
That's why we have we modify the code to make it measure the effective rate. Yes, they're at the mercy of the kernel. What's that time slice actually turn out?
The reason I'm saying the 700 doesn't seem that good is we heard, right, that when something goes wrong in the network, the alarm rate. I think it was Min who asked, right? There were in thousands of alarms that come per second.
Not per device, right?
Okay, so
yeah, so this is it. Just again to set the context. This is first of all, 1 second here. This is to test our ability to cope for the graph to be able to cope with raw, unbuffered link events. Notice we're talking about unbuffered, so there's no accumulator whatsoever. So we actually made the test purposefully harsher. In real life situations, when if we would be dealing with link events, we can actually deal with the individual link events quite effectively with the accumulator, because they will be buffered and produce much smaller number of topology events. So for that particular reason, we decided deliberately not to dig any further, because we have bigger fish to fry.
No, I guess the question is that do we want to optimize on the generator to make it higher rate? Right now it's top end. We don't know what the system.
No, you don't want to optimize on, and the purpose is not to optimize on the event generation. The purpose is, if you say, oh, we are able to, one node is able to handle 300 events or 400 events, that is not a number
that's not a limit, right? We know that's pumped. So we have to get a better generator to get the characteristic of the system.
Well, so perhaps the suggestion is, like, if you're artificially sort of restricting the system, then it's easy to show linear scale out. But the question is, if you have the system near its capacity, right,
Okay.
near its bottleneck throughput for 1 instance, 3 instances, etc., then perhaps the
No,
max
exactly.
graph
We understand that exactly, right? But right now, what I'm saying is that we're limited by the generator, right? But to show scale, you have to saturate one system.
So,
then you can show
what I'm trying to
scale.
understand is that, I mean, again, yes, we have lots of things to do, but is fixing the generator to generate more than 400 events, that is.
I mean, you can just sit there and busy waiting, right? You could kill a thread, don't yield it, and just have a clock that you.
But
All right, so the question is, should we maybe next window?
Guru, the thousands of alarms per second, those were not related necessarily or directly to the topology events. We're talking about various kinds of things. They will not all result in topology events.
I think we can argue about all of that. Question is it really a rocket science to turn that event generator from 300 to 700 or 10,000, right? And
No,
why,
it is.
if it is not, why not do it and see what happens to the system?
Because there's other things to be done. That's all.
How much time will it take to do that? I mean, I think, yeah, you can always say there's a lot of things to do. It's some very common sense thing that you can turn the event generator faster, and that's not a rocket science. It's just maybe an hour's work for somebody to do it.
So yeah, sure, we can do that. It'll just come at the expense of other things. That's all. That's fine. No problem.
Okay, let's start counting hours then. Every hour then, I mean, I think doesn't make sense. This is every time you make a simple suggestion that you can do this, you have to tell me that, oh, it is going to come at the expense of something else. This is not the right approach to this.
Let's take this offline.
Let's take a. So the next one is if you go back to the slides, there will be a link event. I mean, a topo latency measurement. And Andrew is going to talk about it.
And
click on the second link.
click on the second.
Here.
Okay. So I guess in terms of code, there wasn't too much of a change from before. We've seen this from previous sprints. And one thing we improved on this iteration was to scale out single events to see if it had any adverse effects. And as we see that from 1 node to 3 nodes, there's some increase in the latency. But after that, it's stable up to 7 nodes.
I'm not following it. Can you explain what is exactly being measured?
So this is just a single port event. So I have 2 switches with 1 port connected to each other, and we start with 1 instance with the mastership of the switches. So we bring down the port and see when ONOS discovers the event. So there's a graph event as well as a device event. So this is showing the graph event to the OFT message as the latency.
And where should I look to?
So the up average is the milliseconds amount of time it took to discover the port up from the time that the port came up from the switch.
And this is running on bare metal. And
So we haven't transitioned fully to the bare metal yet because we just got them and we didn't have the time to refactor our code to work with it.
You said bare.
So this is
artifact of the.
Sorry. Okay.
This is on the containers that we've had before, but basically we only had a chance to refactor our code and work with the database so we can have a better presentation of these results. So as we move on to the 3 node, you can see that we have 3 ONOS instances, and the switches are connected to ONOS 1, and it's looking at the time it takes to propagate the switch port event across all instances. So that's what you see with the instance 1, 2, and 3. So if you look at each measurement, for the 3-node cluster, you can see that ONOS 1 discovers it in 16 milliseconds, ONOS 2 in 17, and 3 in 17, and so on. And as we scale down, it's the same effect for the 7 nodes. So I believe that.
So, but what it is saying is that the east-west communication is 1 millisecond, the north-south is 16 milliseconds. How do we explain that? That seems counterintuitive to me. So what's going on to?
We haven't had a chance to discuss all this data with developer yet.
I mean, am I making sense? I mean, from your data, is that a reasonable conclusion that the east-west is only a millisecond order, and
right.
North-south is
what is showing.
16? And so, what is going on in north-south? Okay, you don't know.
Well, it's just a guess, right? But on the south, maybe you have more mechanisms before. Well, first of all, you need to go through 2 devices from the switch to the controller, and then the raw message, open flow message needs to be processed and need to go in the graph, right? Once on east-west, you just go from graph to graph. I mean, you are in the same pipeline.
You understand the east-west is the gossip protocol. Just you get an event, you send it out to someone else. That's it, right? So.
And so that's what I'm saying. What is in the north-south?
Like Lucas said, I mean, there's open flow processing.
There's
open flow processing.
Open flow library.
So are there many message exchanges, or this is still a one message exchange? It's just the logic on the receiving
message,
side.
right? Open flow.
Is that a one message or multiple messages?
You measure the open flow protocol, port up, right?
Yeah, right.
Port up time to graph time. There's only one message.
So the message is one, and then all the time is processing of the message inside the open flow driver.
Open flow driver, and then of course put it into the graph, right? Well, I mean, maybe
putting in the graph is
so we have to do some profiling. We have to do some profiling to understand exactly.
Into ONOS, right? So from the raw message, you need to transform the information and put it inside ONOS, right?
So this last couple of iterations, we wanted to focus on, I guess, refactoring our test code as the development team was working on their core. And the conclusion with big help from Luca and Cameron was to put it in the database and make sure we can present it better. And then I guess as soon as possible, we need to talk with our developers to see what's going on, because there was some regression looking at the data from before previously when we had this discussion from the 40 minutes.
So yeah, the big work here, I guess, was to prepare all the test environment and put everything in place. Now we're ready to go, and they just got these results.
Okay.
Okay. Anything else?
No, I guess we're going to be working on the other event performances and solidifying the results, making sure the test is consistent, because we've seen time to time that it posts to fail. It fails to post. So we're working on that, as well as syncing up with developers to work on our numbers and analyze the internals.
So could you please click on the third link? This will be the flow performance based on what we talked about, Ali talked about yesterday. And actually there's some interesting finding. This is running on the bare metal. At the moment, like Ali said, the only way we can push flow is from one ONOS instance. So this is what, let me explain a little bit how we read this. Basically, all the flows are pushed down on ONOS 1, what we call local. And then if you look at the graph, the different bars indicating when it's pushed on local, just without any neighbors, meaning all the flows going straight down to its own switch. And the local plus 1, meaning that it has one neighbor. So it has half of the flow pushed down on its own, half the flow go out to one neighbor. Right? Local plus 2, meaning he has two neighbors. Then he has to split the flow like evenly, push out to the neighbors. So this graph is a little bit different from what we anticipated from Ali talked about yesterday, that when the node increase, the throughput kind of should go down. But this is actually indicating that everything going local, yes, it's a high performance. It's about 500 kiloflow per second.
How much is it?
500,000 flows per second.
Kiloflows?
1,000 flows. Kilo.
550K or 5,000?
5,000.
5,000.
500. I'm sorry. 500K.
538,000.
Right, I know.
500K.
Right,
Okay.
I get the difference.
So going from local to +1,
okay.
It had a significant drop. That's explained by what Ali is indicating. The serialization of cryo may have been the bottleneck of that.
Okay.
But as we increase the number of neighbors, actually the throughput increased. So what I'm reading on this is basically telling me that because the serialization of when you increase the neighbors, the amount of data serialized is reduced. So that, although the total amount is the same, right? But because the lower overhead on the serialization, that's why you get better performance, increasing the.
Why would the serialization would be lower if we have?
Because you have different neighbors, right?
So one possible explanation is that you're breaking the batches up into smaller groups, and so you have to serialize a lot more things in parallel, because each of the sub batches gets broken up onto a parallel thread. So you break the batch up, you're serializing in parallel, you're sending it to a different set of neighbors that are each doing their work independently and in parallel, and then sending the results back to the coordinator.
So that is the more neighbor case, right?
More neighbor case should have more parallelism, both for serialization as well as doing the work.
Okay.
So that's
more serialization and more parallel. That
well,
makes
so
sense. Okay.
There's not more serialization, right? Because you're generating the same number of flows.
Right.
But there's more parallelism in
more
the
parallelism, yes.
Because you're breaking the
exactly. That's how
right.
can be explained that way.
Yeah. Plus, as Swibin pointed out, then you're gonna result, because you're offloading the work onto different nodes, you're resulting in essentially reducing the system load, each individual system load.
Yeah, but I guess still the interesting thing is that for even 7, it is only slightly better than 1. So that is kind of interesting.
What's interesting in two ways. One is, yes, 7 doesn't have a whole lot of performance improvement. The second observation is that with 7, you actually can get better than local, although marginally better than just single instance. That means that serialization at that point is not the biggest bottleneck compared to locally installing code.
Now, quick question: Were you inducing load from all instances, or were you inducing flow pushing just from one?
Just from one at the moment.
That's the reason, right?
Okay.
So that makes
No problem.
Yeah, good point.
Right.
Yeah. Yeah. So, but what would happen if you do it from all instances? Is that a reasonable test to be able to do? Or?
Yes, but by now the code are ready to do that. Right. That is a reasonable, and that's a test that we're planning to do, is push them in parallel in all nodes. But at the moment, the code is not supporting it.
Then it makes perfect sense. This is very explainable. That if you're only pushing from one, I think you said it at the beginning and we missed that. Okay.
But another point I want to point out here is it looks like we're running a 1 gig card, right? 1 gig network interface. That doesn't seem to be the limiter at the moment of performance.
Why would you say that?
Because if you look at +1 and +7, meaning that the limit on the +1 is not because of the network issue. It's not a network interface. +1 and +7 sending the same amount of data out on the network interface.
We have to be careful. We have to be careful because if you're using the 1 gig card, I think the theoretical throughput of frames on 1 gig card is like 1.4 something million frames per second. It's not bandwidth limited, it's frame limited. And NETI, this is one of the reasons NETI is having trouble breaking the barrier, because it does not aggressively pack multiple messages into a single frame. And so I honestly don't know. This is just a theory. So we have to be careful before drawing any conclusions. I think it would be best really just to measure the numbers and then try to understand them with the 10 gig card.
I agree.
I wish do you deserialize on the receiver side?
Do I deserialize and reserialize? Whatever the code that's going to the data.
It's a problem.
It has to be, right?
You have to.
Also get some cost.
Sorry?
The deserialization also has a similar cost.
I know, but right, but
when it is multiple local plus 7, then this CPU is spread across the multiple inputs. It may not be the main factor, but also something.
So serialization is parallelized on multiple threads, and deserialization work is parallelized on multiple machines.
right. So
we should have a discussion about the results, but probably not in this meeting. So are there more in this deck, or is that it?
I mean, the good news anyway is that we can push 500,000 flows per second, right? Yeah. Which is great.
And if you can do it from multiple instances, and if there is a multiplying factor, then that would be terrific to see.
Agreed.
Okay, are you going to do the security demo? Right. So you want to run it from this laptop?
Okay.
All right.
Maybe better to put it in. Download it.
Oh. Okay. Good morning, everyone. I'm Changman from Kite, and I'd like to give an update on our security mode ONOS. And the first major change on this project is, as you may have noticed, title. It's now called security mode ONOS.
Good, thank you.
There was some comments that title is kind of weak, or it's not really straightforward, or it sounds like it's like politically biased. So change our title. So now it's called security mode ONOS. So.
May I make a suggestion? Can you change the most secure ONOS?
Okay. I'll think about it. So today I'm going to talk about the implementation plan and ONOS application permissions that we were able to derive from northbound APIs, and also our future plan until Cardinal release. So implementation plan. This ONOS is a modular project that is based on OSGI framework, and this. Okay. OSGI framework, it has a security layer that supports security features. So we're going to leverage those functionalities that's already there. So for the first access control mechanism, to make sure that ONOS applications only access northbound APIs and other necessary utilities, we're going to use those two types of OSGI permission types. And the first one, package permission, that controls which packages a bundle is allowed to import and or export. And also bundle permission that controls which bundles a bundle is allowed to require. And the work we have to do is that we have to specify which packages or bundles should be only available to ONOS applications. But as you all know, ONOS architecture, they're really nicely separated, so it shouldn't be a difficult problem to solve. And also for our second access control mechanism that restricts non-administrative ONOS applications not accessing administrative northbound APIs. For this one, we're going to use a service permission that controls which services a bundle is allowed to publish and or use. And also, you guys already have those sensitive or administrative northbound APIs into admin services. So we can just apply our access control mechanism directly to those admin services, so that non-administrative ONOS applications won't have access to those admin services. And this is actually a tricky part. For third access control mechanism, this enforces the policy that ONOS application must be explicitly granted permission to make an API call. We're going to use bundle local permission, and this bundle local permission is going to be a logical representation of each type of network operation to be granted, and also multiple APIs performing a similar network operation are mapped to that type of permission. So the figure on the bottom shows how this bundle local permission is going to work. So as you can see in the figure, bundle A and B, and they are like ONOS applications, and JVM is going to monitor the call stack, and it's going to, if class A is on the call stack, and JVM is gonna find out who called this class, and it's gonna check if that callee has appropriate permissions for this one. So this is basically how it works. So I have this example usage of the application permissions, and I try to grant those 5 types of permissions to a reactive forwarding application that's already included in Appleset release. And forwarding application first has to receive packet events. So for that network operation, it has to have packet event permission, and it then has to check if the destination host is known. For that one, we have to grant host read permission, and it's going to see. And then if the destination host is unknown, it's going to just flood all packets by packet out. That's going to require packet write permission. If the destination host is known, it's going to just find out the path and install the flow rules to the devices on the path. And that's going to require 2 types of permissions. And the first one is topology read permission and flow rule write permission. So this is a rough example of how it's going to be done. And so we derived a total 31 types of ONOS application permissions, and this is just the first draft. And I will just post this to the wiki page so you guys can review it later. So there's 2 pages. So our future plan will be improving our permission model until February, and once Blackbird release, once we have Blackbird release, and we're going to actually start coding, and we're either going to contribute the code directly to the master, or we're going to have a dedicated branch so that we can commit the code, and hopefully it's going to appear in Cardinal release. So that's it. Thank you.
I might have missed something in the description. So when you are doing all these permission checks, what happens to either the performance, or how do you do this? I mean, is it an extra memory read for every one of those operations, or?
Extra memory, I don't think it's going to require extra memory, but I'm expecting some kind of performance impact, but we have to test it.
So for the first 2 that he described, they're sort of higher level, they're bundle level or package level, and so for those can actually be enforced the time the application is loaded. For the third type of permission, I guess there's some investigation that will need to be done about the performance. But
the other one, right, where you hear the reactive flow forwarding, in that there were 4 permission checks.
Right, this is the API level permission.
Okay. If you go to the next one, please. Yeah, this one, right? So this is check packet event. So that is a packet write permission, topology read permission, flow write permission. So these are when you're executing, are these you have to go somewhere and check these permissions?
So these checks are all performed on runtime. So there's going to be some kind of performance impact. So we have to investigate it. But I don't think it's going to be significant because it's not always going to it's not, or the ONOS applications won't be performing too much operations anyway. So.
Okay. Okay.
The other thing is the application data store is fully distributed, and so the lookups to permissions would be local on every instance. But again, it's something that will need to be investigated as the implementation starts. But at least for the first two parts, which I think are the first part of the plan, we'll give some high-level protection. That can all be checked at either compile time or.
That is not a problem.
Good, thank you. Okay, so going to SDNIP.
So, you correctly move to the next one.
Yes, I can do that.
Okay, so we have great news this time, right? So better for sure than the last time. We successfully deployed in the test lab of Internet 2, ONOS and SDNIP. Everything seems to work. I just say seems because, of course, we can. No, I mean it works. It works. Okay.
You don't look too closely, it works. Huh?
Yeah. No, I mean honestly, we can ping which peer routes are exchanged. So everything seems to be good. What it remains is to test the failure scenarios. There's no reason why they shouldn't work because at the flow level, so at the compatibility level with the switches, we don't do anything different from what we do already, right? But you never know, right? So it's working. What we did is create a big number of patches that Pavlin developed during the last sprint, and we merged all of them in a unique patch that we cannot merge in our code because it depends just from, are just done to deal with the flow space firewall of Internet 2, right? So it's a hacky stuff that we did just to deal with that component, and we don't want to have that in our code, okay? What's next? The real deployment, of course, right? So on the Internet 2 side, they need to allocate resources in the AL2F network for us. They need to finish to engage the university, and of course, they need to deploy. On our side, we will support the deployment. We are providing them more documentation, of course, our technical support, the packages, all the patches, and of course, we are trying also now, I believe, the failure scenarios in the test lab. And that's it.
Nice. Very good. Thank you.
Bill, can I go next because I need to start heading out here?
Okay, sure.
Yeah, so a quick update on the packet optical use case in ONOS. So as you may remember, we have two epics, two large tasks ahead of us. One is build a software reference platform for multi-layer networks. The other one being building out a proof of concept where we demonstrate ONOS controlling actual optical and packet hardware. So first off, on the reference platform, there's been quite a lot of activity in terms of development, so actual code. First off, Fahad started working on the integration activity to integrate Link better with Mininet. The first first steps were in a way tiny but very important. So, for example, choosing the mechanism of how link and mininet should be communicating is kind of critical. We have been talking to people from Infoblox. We've been talking to the mininet team. We kind of reached a consensus there of what we should be doing. There is Fahad has also been successful in controlling some of the link entities, starting and stopping them. The next task for him will be to really create dynamic elements in link from mininet, which is a fairly challenging job, but progress is already there. Then secondly, I have been working on demonstrating scale-out. So that meant two things. First, I fixed quite a few bugs, or added, it's more adding features to properly support the injection of optical topology and all its annotations of links and devices into a multi-instance environment. That didn't work at all before. That seems to run fine. And then secondly, I've also been working on having a more properly distributed workload of the optical path provision. And then finally, we has been focused on the bandwidth calendaring app, tying up some loose ends there and making sure it becomes a little more feature complete. Can I go to the next slide, please? So in terms of the proof of concept, there has not been any real hands-on work, so to say. There's a lot of planning going on. Remember, this is a multi-vendor activity where we are getting input and hardware and resources from several vendors. You can read them there. We're still on the fence. Spirent is put between brackets because we're still on the fence of whether we will include them or we will need them to really demonstrate what we want to demonstrate. So in terms of planning, there's basically two main activities going on. One is, so Sienna and Fujitsu both told us they have or are very near to completing a TL1 plugin. In Sienna's case, it's based on ODL. In Fujitsu, their claim is it's a more generic form. But gluing that to the ONOS southbound is one of the design activities we're involved in right now. Then secondly, we're also starting to figure out how to extend our multi-layer topology. And specifically, there's a lot of requests from the vendors that we need to include some kind of detail of how ROADMs really look like. So we're averse in a way to pulling in too much detail and pulling in very feature-complete models for ROADMs, partly because of scale, partly because we probably won't really understand what's going on, but also because this is a nice opportunity for us to try and innovate and drive some of the design parameters for ROADMs in the future. So we're taking, in a way, baby steps to come up with a ROADM model that works for the proof of concept, that is compatible with multiple vendors, and that allows ONOS to remain scalable and do its packet optical, its multi-layer optimizations. And then lastly, we're also working again in conjunction with the partners on defining the scenarios and which apps will really be running. Next slide, please. This is a quick overview of what the proof of concept will look like. So let me run through it, say top to bottom. So like I said, we're still deciding on which apps are within reach. So the idea is to show multiple ONOS instances running with two adapters, one for OpenFlow, one, like I said, that glue that RPC southbound adapter that talks to TL1 for Fujitsu and Sienna. And most likely PCP for Huawei. And then you'll see on the data plane, those colored boxes represent ROADMs. It is, at least for this demo, completely out of scope to have data plane interconnectivity on layer 0. That is a very challenging problem that we do not want to tackle, at least for this project. So each vendor is going to live in its own domain, so to speak. You'll have three domains: a Fujitsu, a Sienna, and a Huawei, and they'll be interconnected on the data plane piece on the IP layer, right? So we'll have several Corsa switches, and we're still working out the details of how this connectivity is going to look like, because there's a lot of pragmatic constraints here in the sense of the logistics. Probably Sienna is going to keep well, all vendors are preferring to keep their layer 0 equipment within their own labs or within a designated area, so we can't just like put everything together in one single room. So there's some logistics planning going on how to make this interconnectivity. If all fails, we can still have three fully separate domains being controlled by a single ONOS. We can't then, interconnect over these domains, but we can still control all the various domains. Next slide, please.
Hey, Mark, I have a question.
Yeah, sure.
So, in the interdomain case, how far up the stack does this notion of a domain or a vendor domain permeate? Is it something that stops the plugin? Is it an annotation? I mean, how is it, or is it a new core abstraction?
Great question, and we'll probably have to take it offline because I don't have a good answer. The hope is that we can abstract the ROADM, the layer 0 model, so completely abstracted in the topology. So there shouldn't be any notion there of which vendor is really offering that or controlling that ROADM. And it's only when we go southbound that we'll have to figure out, yeah, it's this vendor versus that vendor. But
if those topology, sorry, go ahead.
No, go ahead.
I think if the topology, if they are not interconnected by physical link, then there is not. You cannot really interconnect them anyway, right? You cannot route traffic, and so the topology.
They connect on the IP layer, right?
Sorry?
They might connect on the IP layer.
Yeah, but IP layer will then go through the Corsa switch, right?
Exactly right.
So then you don't have to worry about it. At least in this particular scenario, you don't have to worry about it.
But we still need to annotate and know which kind of box we're talking to. But that is something, just like we do now, we inject a topology, so we inject another field that says, hey, this device is a Sienna, this device is Fujitsu, and then the southbound will take over from there.
Yeah, that would be great if we could accomplish that with minimal deformation or minimal device specific to the core.
Yeah, so it's really important to not leak in like vendor-specific information in the core, I guess, right? That is the whole point of having this core in ONOS.
Yeah, it's okay to have some fingerprints, identifying fingerprints, high-level ones, but really nothing that the core starts getting, starts differentiating business logic based on that. That should be that differentiation should be entirely contained in the providers and then in the future in the drivers.
And I think the other thing we probably want to be careful of is that we're not creating sort of vertical silos through the core that are vendor specific or domain specific.
Yes.
Absolutely. Yep.
Yeah. It's tricky because every vendor, of course, is trying to push his own model, which models basically everything for the ROADM, right? And they all have different models, different constraints, different implementations of a ROADM. And so we need to innovate here and come up with a generic model that is sufficient, yet sufficient to show everything we want to do, but still complex enough to like please people, right?
Yep, I absolutely agree, Mark.
What is the KVM doing there? What is that?
Yeah, well, Tom put that on there. So it's basically a plan B if anything would go wrong with Corsa. It's an option to have a packet switch, another packet switch vendor.
And KVM is that one? I mean, then why isn't KVM okay? I didn't know.
I can't hear what's being said.
Chips. Yeah. I know. So anyway.
Okay, let's keep going.
Yeah, so that slide needs to be reworked, and this is gonna be like the main slide that's gonna be like the driver for the whole POC. Anyway, so moving on, I decided to put this in the packet optical. It's maybe not exclusively related to that, but we just started a new activity on NetConf. So as you all know, a lot of vendors and carriers have been telling us, yeah, NetConf is really important. It's really great. You really need to support this in ONOS. So as a team, we kind of decided, yes, it's important, we agree, but we need to focus on building a core that can support everything. But recently we were approached, this Producta came up with a company from India called Happiest Minds.
You there?
He became very happy.
And so, is there a question?
No, you just dropped off.
Okay. Okay, so the idea is that they will do the implementation of a southbound NetConf protocol, right? And deliver that by the Cardinal release, so end of May. And there's going to be Ali and me to follow up and like help them in figuring out where to do what in ONOS. So the initial idea is just to do the protocol implementation, and while doing that, the largest creative component in this activity is that we get to design and implement a new ONOS config API. We have some ideas, but they're all fairly blurry right now, and we haven't really nailed down any details. On top of that, of course, it's all good and well to implement a new protocol, but what are you going to do with it? So we're also thinking of what can be like a minimal set of models or demo scenarios we can demonstrate with this new southbound protocol. And I guess that's it for now. Any questions?
All right, back to TV6.
Didn't check Google presentation.
The top right. We'll just open it in another tab.
Yeah, it works. Okay. Good morning. This is about IPv6 Scrum, which is not the Scrum. And this is kind of unusual development because first it is low priority, and also there is a lot of external interest in making the progress. So on my side, I practically work on it when there is nothing factored like intensive deployment. On the external development, the folks they work when they just like to work on it. One interesting thing which happened this sprint was there was a new external participant, Dusan, from the academic network of Serbia, who is network engineer. He just started testing IPv6. He found some bugs, and very unusual for network engineer who claims he is not developer. It's actually not very good fixes. Can you go to the next?
DevOps personal living.
Okay, so this is what we did this day. He finished the network discovery proxy. Then from the sun he found a number of bugs and fixes. On my side, I finished the selector and the for IPv6, and there was the side effect of adding a few selector-related bugs which were fixed. And can you go to the next slide? So this is a list of leftover things which we basically
link.
Ellie. Okay, so this is the list of things which remains to be done. Now we have practically all pieces in place, like the selector, also the basic packet support. And code-wise, the first one is which remains the cost monitoring. And then we have also to do the integration and putting things in place. And can you go to the next slide? So I think, assuming there are no other side tracks, I think we are still on track to deliver what we said earlier for 1.1 release. And that's it. Any questions?
Thank you. Great community effort. Okay. All right, and should I run UI from here? Simon? You're going to run it? Okay. So I should give you the permission to. Okay, so, you're now to present.
All right, so I'm Bree and I'm working on the GUI with Simon. This sprint, we've been working on implementing the topology view. Our goal was to have it look like the original GUI that we released with Avocet. Then we also wanted to do the device view, which I've been working on, that has, and our goals for that was to have the table for the devices, react to window resizing, and have headers for each of the rows of the table be sortable. So when you click on a header, that information will be sorted by that column field. We also wanted to do the flash service, which is like when you a message would pop up. So he just did. We also wanted to do the veil service, which was just decided to change that. That comes up when you lose WebSocket connection. So like when ONOS is killed, it'll pop up and say that you don't have any. So we achieved a lot of the topology view. It looks pretty similar to what it had originally. There's a few things I finished. It has traffic visualization. It shows devices, hosts, links. It also shows the instances, the summary, and detail panels like the previous one did. What's new is device list. We used Angular directives to have a scrolling body header. Oh. Yeah, so we have the body stay in one place, and you can click on each of the header buttons to sort the information by that, and icons appear depending on which way the information is sorted, which I'll show you in a moment. We also implemented the flash service, like I said before, which is when you click a button, it'll say which keys are pressed. What's slightly different about that is that in the previous version, when you clicked a button and then clicked a new one, it wouldn't show the new message immediately, but we changed that, so now the new message will appear immediately. And then the veil service is completed. And something new about that, too, is that you can't press keys when the connection has been lost. So what it looks like. The topology view looks a lot similar, very similar as it did before in the original. Got like the summary panels, and you can move devices around. Flash service is like that, where it brings up a message. Can take away the background, the back, different themes. You can make the panels go away. The device view, which I've been working on, is just like this. We have our table of all the devices that are currently connected to the ONOS instance. It says how many there are total. It has whether they're connected or not. It says what kind of device it is with an icon, so that's a switch icon. Oh, well, that's our Veil service. That works. Yeah. And this is our table that scrolls, and it changes, the size changes depending on the size of the window. So you can dynamically change the size of the window, and the table will adjust. And the sortable headers are, if you click on the top, it'll say whether it's ascending order or descending order sorted. So right now it's sorted by device ID. Right now they're all sorted by strings, so if you wanted to sort by the chassis, it's sorted as if they were strings, not numbers. But that's something that we're going to work on. But all of these at some point. All of these will be sortable. And since the information looks really similar right now, it doesn't change all that much. But we'll have different information for when we use it for real. The only thing we missed was the oblique view and the packet optical layers filters. Those were in the previous, but we don't have right now. And for the next sprint, we're going to have the quick help panel so you can see which keys you can press to have different options appear. We'll have auto failover. We'll have the oblique view, which is where you can see the different layers, and then you can filter which layers are appear.
Yeah. Thank you.
Great job, guys.
Apparently he can see the slides just fine, but he can't hear anything. Maybe that's
Is he supposed to see from
here?
All right. Testing Wi-Fi.
Hello everyone. I'm going to be giving a quick update on the QA team. So on functionality part, we have new test cases for the listed tasks. We can migrate hosts on the fly dynamically. We can add single hop intents and verify. We've been testing single hop intents with respect to point intents. These hosts are connected on the same devices, and this test case was based on one of the bugs that was cited in the community, I guess. And then we also have a test case that verifies if the expected number of people flows are installed on each device in the active forwarding mode. And then we kind of uncovered a bug, 101.7, which is this file is blocker while testing these new test cases. For HA, John has been refactoring the old test cases. He's also trying to add new test cases for control plane partition, but a lot of these tests are being tested manually for now because he has some outstanding bugs which are hindering him to have his tests run in an automated way. For Cho, Ari has been implementing 2 new topologies. He also has I-forward test to all the 3 topologies, and then Kelvin has been working to give us a proof of concept to have all our test on Java functions being implemented in a multi-threaded way, which would improve our performance of our tests, especially the Cho tests, because the Cho tests have been running for like almost a week. So if we have this multi-threading in the driver functions implemented, we could probably be writing our two test results. And so this is the stats of the bugs. So since Abacus released, the number of bugs filed are 100. Previous one, which are in the parentheses, which means that from the last sprint, there were 76 in the last sprint, and this sprint we have like 100 bugs filed. In the last sprint, there were 15 in the resolved state, and still there are 15 in the resolved state. So it doesn't seem like there have been any bugs in the resolved state in this sprint. In the last sprint, there were like 28 bugs which were in the closed state, and we have 42 now. So that's a good thing, like from resolved to closed removed. The total number of bugs that are open and are in progress are 58, which is from 50 from the last sprint. And then we have 3 blocker issues, and these are mutually caused. Did anyone have any questions?
Your echo.
So we have like 3 blocker bugs which are outstanding for the QA team, and then in the coming sprint we are going to be working parallelly also on regression tests based on all these bugs that have been filed, and all these numbers are from 3 p.m. yesterday. And that's it. Anyone any questions?
Okay, let's see. I think that's everyone. Did I miss anyone?
There's 2 more, I think. Patrick had one, and I'll leave a course update on the agenda. Okay. It should be delegated to Jonah.
Yeah. Okay. Are there slides or not? Okay.
Let me talk about. So there's been a bunch of work on the corporate stuff done by a lot of different groups. The first thing is Shrikant and Sangha have been working on the group provider stuff, and I think they've finished the implementation now, and that's all enough. So that's good. We can start using that to provision groups on the switches, which we need for the next talk for routing. Ali has built the preliminary Corsa switch driver, so that's sitting in Garrett, and we'll need to test that when we get the application built as well. But the main driver outline is there. And I've been working on some of the application stuff that we need to do. So this work is, we want to build a separate BGP router application that leverages a lot of the STNIP code. I've been rearranging STNIP code and also starting building the BGP router application. So all the RIB maintenance and getting BGP routes will be the same code as STNIP, but we'll just do things slightly differently when we actually try and program the data plane. And so that's what the changes there are going to be. And so I'm still going to be working on that next sprint as well. And then also Shrikant and Sangho have started sort of adapting Ping's original STNIP tests for the Corsa deployment setup. So it'll be great to have some automated integration tests so we can fully test out the whole system before we try and deploy on hardware. And so that work will be continuing next month as well. So that's all from Corsa.
And what was the last one?
There was a slot for Patrick. Did you have some updates for IPRN or?
Oh yeah, the IPRN, yes. So I don't have your slides. Basically, we are happening. So one is we have those APIs, Flow APIs working, and submit the code review. So we already go through the cycle. So we are working on the comments from the TASP teams. So for the other things, we also work with the TASP teams on the next on our requirement. That is packet in and out, and the topology enhancement, and the tunnel network of provisioning, and MQRS label application. So here is something for on the IP1 use case. So here my update. So in the meantime, we also work on this MPRS label management the code. So, yeah.
Okay. Good. Thank you. Anything else? Any other questions, comments?
I think the Willie, do you have something about the PCEP's 5 update?
PCP.
Yeah, the IP plus optical. So I think we probably can give the update.
Okay. So we are going to demo the IP optical integrated with ONOS at OSC on March. So we have finished the development work and trying to put it together for the comprehensive testing. So we're almost done. So for the whole thing, we can to show you that oversee. This is the PCEP southbound for ONOS controlling your real hardware devices? Yeah. So we big idea. So we use the PCEP southbound. So we use ONOS in the car, and we developed the multi-layer PCEP northbound. So that is the whole. Are you going to open source the PCEP plugin? It's a large amount of work, so it's using IC. It's obviously not a.
I think the one thing you probably need to clarify this to the people here is basically we are taking approach to quickly integrate the current what we have with the ONOS. We try to prove the integration concept. Okay, so on the southbound we are not implement the complete the PCEP stack in the southbound. What we are doing here is we implement a southbound agent to talk to the external the protocol stacks. So currently is the implementation. We just want to get this done very quickly and run the demos. So the phase 2 later on, we'll try to move this external the PCEP and add it to the ONOS southbound.
Yeah, we plan to maybe so in the next month, so we are going to move the right of the PCEP to Java or right now, as a Mike showed, so we are for the RPA optical group, so we are thinking about to develop some the RPC so far, so we can target the vendor specific provider, which I mean can be using in C and C++ or every kind of provider. So we just need to make a small changes on the service and the vendor so far. So we don't need to rewrite the whole thing. Understood. Yeah. But when you integrate that in the next phase, then you integrate the PCEP protocol in southbound. Are you going to? The plan is to open source that, at least the vendor agnostic part of it, and then.
I think this we need to talk about this. And, based on current information I have, yes, we are ready to open source that. But currently we're in-house build was in C language instead of in Java. So if convert to the Java, it's the actual engineer effort. It definitely need planning this one in future. Yeah. If it's urging the top priority, definitely from our side we can adjust the priority.
I don't think it's urgent, but once you have the PCEP plugin, outsourcing and open sourcing it will be good, and everybody can see how you can put plugin into ONOS, right? That's a good thing to demonstrate.
The other thing is there's no strict requirement that all code that's sort of sitting around the project is written in the same language. And so if there's an RPC mechanism between a southbound sort of provider or server and client side, then it's certainly going to be more useful for someone to be able to look at both sides of the RPC. And so, if your plan is eventually to make it Java and everything sort of as one big provider that goes into ONOS, then that's great. But if you think that there's a compelling reason to sort of show how you can have code that sits outside ONOS and an adapter to ONOS via some RPC mechanism.
Oh yeah, sure. Yeah, it's, of course. Because I think the rule asked about is the open source PCEP stacks, right? If we're running the outside of the ONOS, how can we open source that?
No. So I don't know what is the PCEP stack. I'm only interested in southbound plugin. Is that just a protocol and a plugin, or there is a, what do you mean by stack? TCP stack?
So TCP is the protocol, right?
Just the plugin is what is interesting. Whatever your algorithm you're running on top, that you can keep it proprietary. And
No, the point is that they've written the part of the plugin that talks to the device.
Right.
And then they're going to have an RPC between that and a shim provider. You know, you could go either way. And if there's a compelling reason to keep pieces of code in another language, it may not be part of the ONOS proper code base, but you know, it could be a project that we hope to support around us.
Sure. So basically, there are two ways. One is based on the RPC, another is directly interface with the ONOS. Okay. We take this outside. Okay. We got one more thing I want to bring up here, and that's the statistics. Lucas done just an amazing job pulling together statistics from all over the place and putting them into our usual wiki, not even wiki, our web page format. Go ahead, tell us about it.
Well, I was moving things earlier. It doesn't work. Can I?
You want to come here?
Yeah, use just one second. So nothing else. Bill said I put together these drivers to get the information on our basic statistics on our basic metrics we have for now. So you have per day and monthly statistics for Jira, day by day, are updated hour by hour. Jira on its website, wiki, the packages that we have online, the TarGZ and zip downloaded. On every graph, you can rescale the graph and select a range of dates, and of course, Gary. So, and then you have an aggregate that tells you till up to a certain date per tool what's the amount of interaction with that tool. So it aggregates together the information. I'm going to create also a plugin for Gerrit. Should be almost ready to count exactly the number of clones. And that's it. And the idea is to create also driver for YouTube and Git. And with this, we should have all the statistics we need maybe in place. Okay. So you can access to the page stats.onosproject.org. And that's it.
Yeah, nice. Thank you. Okay, so a little over, but not too bad. Anything else? Anything online?